this is question 25 on the higher calculator paper. Just reading through the question to begin with. The question says, Carolyn has 20 biscuits in a tin. There are 12 plain biscuits, 5 chocolate biscuits, and 3 ginger biscuits. And all three of these, 12, 5, and 3, add up to 20. Carolyn takes at random 2 biscuits from the tin. Work out the probability that the 2 biscuits were not the same type. So we want to work out the probability that the 2 biscuits are not the same types of biscuits. I'm actually going to use a tree diagram to actually do this. So I am going to use a bit of space. So if I start off there and I have my 3 possibilities, right? The 3 you could do this freehand, and sometimes I guess it may well be better or quicker to use it freehand. In fact, I think I'll do the next part of it freehand. We have plain biscuits, chocolate biscuits, and ginger biscuits. And if I do the second part of this, so we've got plain, chocolate, and ginger, plain, chocolate, and ginger, plain, chocolate, and ginger. Okay, so that is my tree diagram for this question. If I just move this up so you can see all of them, what I'm about to do now is to put in all the probabilities before I do the last phase of this. The 12 plain biscuits, and there are 20 of them altogether, so that's 12 out of 20. There are 5 chocolate biscuits, so that's 5 out of 20, and 3 ginger biscuits, which is 3 out of 20. However, Carolyn takes at random 2 biscuits from the tin. Work out the probability that the 2 biscuits were not the same type. So after she picked the first biscuit, she picks another one. They haven't said that she replaces it, and that we don't make that assumption. So that means when she takes the second pick, there are only, this time, 19 19 biscuits in the tin. If she picked a plain one the first time, there's going to be 11 in the second turn, right? And how many chocolate biscuits, or what's the probability of picking a chocolate biscuit here? Well, if she picked a plain one first, that means that there's still going to be 5 chocolate biscuits in there, so it's 5 out of 19. And for the ginger biscuits, that's going to be 3 out of 19. Check that the probabilities add up. 11 plus 5 is 16, plus 3 is 19, so that's 19 out of 19. They all should add up to 1. So we're going to do this for each of the branches. This one here, we've still got the 12 because we picked the chocolate first, so it's 12 out of 19. But because we picked the chocolate first, there are only 4 in there the second time round, and you still got your 3 out of 19 there. Let's just check that. That's 16, and 3 is 19. In this case, I've picked a ginger first, so I have 12 plain biscuits, so that's 12 out of 19. This is chocolate, so that's 5 out of 19. And finally, here, because I picked a ginger first, there are only 2 of them left, so that's 2 out of 19. And let's just check that. 12 and 5 is 17, 17 and 2 is 19, that's 19 out of 19. The question says, work out the probability that the 2 biscuits were not the same type. They were not the same type. So basically working out the probability that they're different. So if I work my way along the branches, that's plain and plain, so they're the same there. That doesn't count. That's plain and chocolate, so I want to work out the probability there. Plain and ginger, yep, I want to work out the probability there. Chocolate and plain, yep, different. Chocolate and chocolate, nope, they're the same type. Chocolate and ginger, those 2 are different. Ginger and plain, ginger and chocolate, those 2 are different. And ginger and ginger. Okay, so I'm not interested in that one because they're the same. If you want to work out the probability at the end of a pair of branches, you times the probabilities along it. So that's 12 out of 20 times 5 out of 19, or 5 over 19. 12 out of 20 times 3 over 19. 12 over 20 times 3 over 19. This next one, 5 over 20 times 12 over 19. 5 over 20 times 12 over 19. And 5 over 20 times 3 over 19. 5 over 20 times 3 over 19. And final, oh well, no, I did two more. 3 over 20 times 12 over 19. 3 over 20 times 12 over 19. And 3 over 20 times 5 over 19. 3 over 20 times 5 over 19. Now the denominators in all of these are going to be the same. That one there is going to be, well, 20 times 19. 2 times 19 is 38. So 20 times 19 is 380. They're all going to be 300. They're all going to be out of 380, and that's going to be helpful when we add up all of these fractions. Okay, so 12 times 5 is 60. 12 times 3 is 36. 5 times 12 is 60. 5 times 3 is 15. 3 times 12 is 36, and 3 times 5 is 15. Now, if I need to add all of these fractions, add these together, I'm just going to add the numerators, the numbers at the top. 60 add, actually, before I do that, I know, because all these fractions are out of 380, I know my answer is going to be something out of 380. If I just move this upwards, so my answer is going to be some value out of 380. If I add all the numerators, so adding these together, I've got 60, 36, 60, 15, 36, and made a mistake there. Delete, 15 plus 36 plus 15 equals 222. I think I'm going to check that again, just in case. So 60 add 36 add 60 add 15 add 36 add 15 equals 222. So my final result is 222 over 380. Note the question didn't say anything about simplifying or putting it into some other fashion, so I'm going to leave my answer like that, 222 over 380, and that answer is acceptable and correct, right? And you should get full marks given this. This is a 4-mark question. There's quite a lot there for 4 marks. Make sure you do get it.